Hello everyone, how are you doing? I encourage you all to open your textbook to page 57. We will have another activity, but this time will be a simulation activity, not a video. So we'll have, as usual, a prediction question. What do you think will happen if? This is usually the prediction question. So, how does temperature affect the state and mass of different type of matter? Meaning, when you heat liquid or when you heat solid, all right, does the state of matter change? Or when you freeze liquid or when you try to freeze solid, for example, is the state of matter change? So the question here, does temperature actually affect matter? Yes or no? So this is our prediction, and if it does, how does it, how it's affected by it? So think about it for a minute. The answer for the prediction question will be this one. Changes in temperature can change the state of matter. The matter's mass should stay the same. All right, the mass should not change. All right, but state of matter will change. Meaning, if we took ice cube out of the freezer, it will melt after a few minutes, right? It will melt. So the state of matter, it changed already. It's changed from solid to liquid. But the amount of water, right? The amount of water did not change, all right? Did not change. So the mass does not change, all right? Please copy the correct answer in the box. Next, we will have a look at the simulation. All right. So we have a flask. This is the flask, all right? And we have, of course, the thermometer here. You can look at it. And we have are the particles of the matter that we supposedly testing. So the first substance inside the flask is iodine, all right? It's mentioned here, is iodine, all right? And the mass of the iodine is 500 grams. I want you to focus what will happen to these particles when I start to increase the temperature gradually, all right? So the thermometer here will start going up, all right, as I move the triangle here. I want you to observe what's happened to these particles. So right now, the particles are tightly packed, right? The space between these particles are very little, all right? So most probably could be this is a solid particle because it looks like a solid particle to me, all right? What happened if I took these particle and start to heat it, all right? They're right now vibrating. Remember, solid particles vibrate, do not move. So it looks like vibrating to me. What's happened when I start actually heating the iodine? Let's watch. I'm gradually starting to heating. Do you see how the vibration become more and more? Now there is a vibration and movement. Look, look what's happening. They are vibrating faster and faster because I'm increasing the temperature. I'm increasing the temperature. Do you see the fire here? I'm actually increasing the temperature. It's now above zero. Not sure how much here, but I am increasing it, all right? Look, it's not the same. I will keep increasing the temperature. The movement becomes faster and faster. See what's happening. See what's happening. See what's happening. The state of matter definitely is changing. What do you think this state now? It was solid at the beginning, right? What this represent? Does it represent liquid to me? Solid or gas? They are scattered all around the place, remember? They are scattered all around the place. So technically this is gas now. Do you see what happened? It changed from solid to gas. See what's happened when I keep increasing now. I keep increasing. You see the movement of the particles of the iodine. I reach now 200, right? 200. Do you see what's happened to the particles? Look, it's now filled with gas here. Do you see? Completely purple. It changed from solid to gas. So it was minus 10. It was solid. And when I increase the temperature to 200 Celsius, it completely transformed to gas. Let's see the second substance, which is ethanol, all right? Ethanol is like rubbing alcohol. It's similar to rubbing alcohol, the one we use for medical reason and sanitizing, all right? It's similar to it. So technically it is, what do you think the state of matter here? It doesn't look like the iodine, right? Does not match with the iodine. The iodine was vibrating so closely together and the spaces did not look the same. So figure out, what do you think the state of matter here? Is it solid, liquid, or gas? To me, it should be liquid. So anybody who answered liquid, you are 100% correct. Let's now, when it's minus 10 Celsius, it is liquid state. Observe, please, look at the particles. What happened to the particles when I increase the temperature? Observe what's happened to the movement of the particles when I increase the temperature gradually. Until I reach 200. Now I'm at the 200. Do you see the movement? It's totally different. So it changed from liquid to, what state of matter is this? It's gas, okay? It's gas. Let's move to the last substance, which is olive oil. At minus 10 Celsius, do you think olive oil will stay liquid? All of us know olive oil is liquid, right? We use it in our salad, we use it in the sandwiches, we cook with it. Olive oil in room temperature is, it's liquid, sorry. What happens when we freeze the olive oil? Put the olive oil inside the freezer. What will happen to it? It will freeze, all right? So it will turn to solid. See how the particles are vibrating? The particles are vibrating and tightly stacked together, all right? Tightly packed together. So the olive oil is solid. Observe what happened to the olive oil when I keep increasing the temperature. All of them have the same mass, huh? All of them, the mass is 500 grams. Do you see how the particles of the olive oil are scattered around? Do you see? When I reach 200, they are all around that place, all right? Not packed at all. So technically, this is liquid, all right? Still liquid, not gas. It's very, very hard to turn olive oil to gas. I know your first answer will be that this should be gas, but it's not. It's still liquid, not gas, all right? Because olive oil, it needs a really, 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 really high temperature, more than 200 Celsius to turn it to gas, actually. All right, to actually burn it, you need a really, really high temperature. It's not a simple process, all right? So it's still liquid, but very, very hot liquid now. But the change in state of matter already happened, all right? So this is the simulation for this activity. So on the table on page 57, please copy the correct answer. Iodine at minus 10 degrees, it was solid. Then when we heat it, it turned to gas. Ethanol at minus 10, it's liquid. Ethanol does not get freeze, by the way. And when we heat it to 200, turned to gas. And the olive oil at minus 10, it was solid. When we heat it, it turns to liquid, all right? It did not turn to gas. It turned to liquid. So question number one, explain the movement of particles as you add energy to each substance. The energy we added is heat, all right? So when energy is added, the particles speed up and start to spread around. So this is the correct answer for number one. Please copy it in your textbook. Number two, what happened to the mass of the material in the simulation regardless whether the heat is added or removed? If you focus on the number 500, you notice that the number did not change. So the mass did not change. The mass of the material stayed the same. Only the state of matter changed. All right? Please copy this answer in your textbook as well. All right, this is the correct answer. Thank you so much for watching. Have a nice day.